Here's a question. You have a list of words. What's the longest prefix that all of them share from the start? So if I gave you flower, flow, and flight, what would you say? Pause for a second. Look at the letters. The answer is full. Every word starts with F, then all. The third letter breaks the pattern. And if no shared letter exists at all, like dog and race car, we return an empty string. That's the whole problem. Okay, try the obvious thing first. Take the first two words and find what they share. Then take that shared piece and compare with the third word. Flower and flow share F-L-O-W, so our running prefix is flow. Now compare flow with flight. Flow and flight share F and L. At position 2 we have B versus I stop. Prefix shrinks to full. It works. But notice the waste. When we matched flow against flower, we compared the do and the o. Those letters were never going to survive flight. We did extra work past the real answer length, and we did it on every pair. That's the flaw we want to fix. Okay, let's slow down. What if we flipped how we look at this? Instead of word by word, what about column by column? Look at the first letter of every word at once. F, F all match. Move to column 1. Column 1, L all match. Column 2, O, I, stop right there. One word disagrees, so the prefix ends. That's the move. Walk down the columns. The instant Owen word disagrees, or one word runs out of letters, we're done. And here's why this is better. We literally cannot scan past the answer length, because the mismatch is the answer's boundary. Quick watch out. You might think we need a special case when a word is empty or shorter than the others. We don't really. If column 2 doesn't exist in some word, that word ran out. Stop. Return what we have so far. Same rule, same bail. Let's trace it cleanly. We'll use the first word as our guide, and check each of its letters against every other word in that same column. Column 0. Guide says F. Is flow's letter at 0 F? Yes. Is flight's letter at 0 F? Yes. Move on. Column 1. Guide says all. Flow has all. Flight has all good. Slide forward. Column 2. Guide says O. Flow has O. Fine. Flight has I. That's not O. Mismatch. So we stop. We return whatever the guide had up to, but not including column 2. That's an all. If we'd finished every column without a mismatch, it would mean the whole first word is the answer. So we'd hand back the guide itself. Notice what just happened. We never scanned past column 2. The vertical walk EXPLOITS. The fact the answer can't be longer than the shortest word. So how expensive is this? In the worst case, we touch every letter of the answer, once per word. That grows with both the word count and the answer length. And we don't build any extra structures. We just remember the guide and the column index, so the memory is basically nothing. Let's write it. The skeleton is a class with one method, and we'll handle the empty list up front. We grab the first word as our guide, then loop over its letter positions one column at a time. Inner loop checks the same column in every other word. If the word is too short, or its letter doesn't match, we bail and slice the guide up to here. And if we make it through every column without stopping, the whole guide is the common prefix. Hand it back. And that's the pattern. When pairwise feels wasteful, flip the loops and walk by column instead. You'll see this trick again.